Okay, so in the last lesson, that was lesson number 7, we learned how to use the line follower of the mBot to teach it how to follow a path that's defined on the floor. So in this case now what we're going to do is, and starting on this lesson, we're going to start taking elements from lessons that we used before, and implement all those sensors and all those things the mBot has, like the integrated speakers and the LED lights, to do something that I call traffic simulation, which is basically teaching the mBot how to behave like a person that's driving on the street. And to do this, we need to use all the elements that we've done before. We need to use conditionals, we need to use loops, and we are going to make this program based on the line follower program that we did before. So let's take a look at what we're going to do now. So like I mentioned, we have to use some of the elements that we used before. Even though you could also use the integrated speakers, I decided not to do this for this lesson. I thought maybe using the ultrasonic sensor, line follower, and LED lights in a single program could be a good example. So what we're going to do in this lesson is teach the mBot how to behave like a person that's driving on the street. And to do that, obviously it's not super complicated, but we're going to teach the mBot how to react to two main events. One is what the mBot has to do if there is an object ahead. Obviously, if you were like a person that's driving on the street and there was an object ahead, you would have to stop, not to avoid crashing, and you would have to wait until whatever object is in front of it moves. So that's what we're going to teach the mBot how to do. And the other thing the mBot is going to do is how to react to the stop sign. In this case, a stop sign, it's not an actual stop sign. It's represented by a missing uh, piece on the track. The mBot is going to uh, react once it misses this spot. It's just going to do something. In this case, it's going to move, wait, like it's waiting for someone to cross the street, maybe, and then start moving forward um, regularly to find its path again. So, okay, the requirements, as I already told you for this lesson, are just the line follower, the ultrasonic sensor, and the LED lights. And the objectives that we're going to do in this lesson, I basically already listed them out for you. It's very similar to the line follower project we were doing. However, on top of being able to follow a path and react to whatever turns the path has, the mBot needs to react if there is an object in the way, and using the ultrasonic sensor, of course. And the other thing is that the mBot is going to make a brief pause to pretend like there's someone crossing the street. It's going to turn the lights on to show that it's stopped, and after that, it's just going to move forward and find the path again, and continue moving on the circuit infinitely unless you turn it off or it runs out of battery. Okay, I wouldn't like to spend too much time in the analysis. I basically already did that in the presentation, but all we have to do, be aware of, is that we're going to be using all the elements from previous lessons. It is important that you know how to use the ultrasonic sensor, how to use the line follower, and how to communicate with the LED lights for the mBot to simulate certain action. But after, if you know how to do those three things, there shouldn't be a bigger problem. And the other thing is that this program is built on top of the line follower program. So if you already built that from the last lesson, I'd recommend you save it. Of course, if you have saved it, you could open it. This is what I'm going to do actually in the coding part of this video. You could open it, and we're just going to edit some things to teach the mBot how to do something. So now let's take a quick look at the flowchart that represents the program. So even if you don't remember very well what the flowchart looked like for the last lesson, um, it's very similar to what we did. Um, this is the program for the traffic simulation, and if you remember the flowchart for the line follower, it's very similar to this. Actually, from the block that says start all the way to here and all this section, it's the same thing. all we're going to do now is add a few things, which is this section right here and this, which would be basically function B. It's connection B. But let me explain again from the beginning. The program is going to wait for you until you press a button. I didn't list it here, but we're going to give it a few, probably 1-2 seconds, and for you to move your hand out of the way. You're going to the mBot is going to calibrate, where it basically turns to the right on the same spot until it finds its path. And then it's going to start reading the values returned by the line follower. If you remember from last lesson, it can return values from 0 to 3. And depending on this value, it makes a decision whether it has to turn to the left, to the right, or move straight. And the last lesson, however, what's different now, while it's reading the value from the line follower, it's also going to be reading the value from the ultrasonic sensor. And in this case, I decided that if this value is less than 6, what the program is going to do is tell the mBot to set the line follower value to 3. Um, of course, 6 is in centimeters. If you wanted to do this in inches, you would have to make a few conversions, because the ultrasonic sensor, it returns a value in centimeters. But in this case, I decided that the mBot is going to stop if there's an object ahead that's at less than 6 centimeters. But um, basically, if you remember from the line follower program, once the value from the line follower is 3, the strategy we had defined was that it's going to go backwards to find its path again. In this case, we're going to change that, and we're going to go to function B, which is this one. Um, all it does is it stops moving first, then executes the light stop signal. That's nothing else but then turning the lights on, red lights, LED lights, to show that it's waiting. It's going to turn them on and then off again, just to show. It's going to do it this 3 times. You could do it less, you could do it more. I'm going to show you how to use a for loop, which it's used by the repeat block in the M block and Scratch. Um, but basically, it's after it executes the light stop signal, it's going to make a decision if this signal was executed at least 3 times. If it wasn't, it's going to do it again and again. Once it was done 3 times, it's gonna move forward, which follows just by moving straight ahead until basically it finds a path again. In which case, it's just, if it doesn't find a path, it's just gonna go back and keep moving forward until it reads the line follower reads a value that's less than 3 and finds its path again. Once it does, it's just gonna go back here. It's just gonna keep reading the line follower value and reading the ultrasonic sensor value, moving on. Okay, so for the coding part, as I told you, in this case, I already have this project loaded. This is the line follower project we did last time. All you have to do to load a project is go here where it says File, Load Project. In this case, I already have it loaded to all the programs that I've done. But if you don't have that, just search the program over there and load it, and it's going to work. In this case, we're going to have to edit a few things. So the first thing I want to do, this is going to stay the same up until here. The calibrate function, it's basically the same thing. It's basically the same thing up until here. Once we reach this point, we're gonna use the forever loop again. However, we're going to edit this function that we called in the last program move. We're going to press here. You're going to press the left click of the mouse, press edit, and this time we're going to call it traffic simulation. Oops. Simulation. Okay. We're going to put it again, and this is basically what it's going to be running forever. And as you can see, mBot does this for you, where it actually edits the name of the function here and anywhere you have where you had it in your basically your work area. What I did after this is that we're also going to create a function that's called initialize. There you go. It's going right here, and we're going to need to set a couple more variables. One is, well, it's just one actually, and it's called object ahead. That's what I called it. And now we need to use these blocks. So we're going to set the line sensor value to the line follower. That's right here. Just going to copy it from here. Takes a little more time to search on the other side. And we're going to take the ultrasonic sensor value from port 3 as well. And that's all you need for your initialize block, actually. However, we're going to call it from here. And we're going to call it from here because this has to be done continuously. If you wanted to call it from, let's say, here, and you decide to initialize your variables all the way here, this is going to happen once. There you go. If you wanted to do that, these values, the mBot would read them from the sensor once at the beginning of your program, and that would be it. We have to put them here because that way the mBot is reading the values from those sensors continuously, since we're running this block from the forever loop, and this is being run here. So once we have those values, we're going, this stays the same except for one thing before. Actually, I don't think we need this anymore. Delete. Yeah, because we already have it here. What we're going to do is we're going to add one more condition, which is called if then as well. And in this case, what we're going to do is use our operators, our comparisons, to check if our object ahead, which is, oh, I didn't change the value of this, object ahead to the ultrasonic sensor value. If the object ahead variable is less than, and I said 6, of course you could make it something else, then what we're going to do is that we're going to set the line sensor value to 3. Okay, and as we know, what happens, well, up until now, what happens when we have the line sensor value turn into a value of 3. Right now it's that it runs backward. However, let me delete this. We're going to make a couple more, this function called react, and I call it react because it's basically what it's going to do when there's an object ahead and when there's a stop sign. If you remember from the traffic simulation, the line follower returns a value of 3 once both sensors on the line follower cannot find a path. So in this case, if in our circuit there's going to be a section that's missing, and that's going to represent a stop. So this action can be performed as well to simulate a stop because there's a path missing and both sensors are going to be returning a value of 3. So now we're going to call this function called react from here. And what we're going to do basically is that the mBot is going to stop. And to tell the mBot that it has to stop, all you have to do is grab this block that says run forward and set the speed to 0. And that's basically how you tell the mBot to stop. Afterwards, we're going to use one of our control blocks. In this case, it's the one that says repeat. And I'm going to repeat this 3 times. What we're going to do is that we're going to set the LED lights There's, yeah, this one. Set let on board all to, we're going to be turning them on red. It's going to wait 1 second, and then it's going to, let me duplicate this, turn them off, and then it's going to wait 1 second again. It's going to do this 3 times. It's going to repeat it 3 times, and once it does that, it's gonna go back at this point, which is basically, if we were looking at our mBot program, it's just gonna keep running forever. So at this point, the mBot would basically wouldn't know what to do. So we actually have to tell him what to do in order to find its path back. So I call this other function find way back. It's up here, and all you have to do is call it after it reacts to either an object or a stop sign. And what you do for it to find its way back is that we're basically going to copy the code from the calibrate. However, we're going to change this one to run forward. That way, um, in order for the mBot to find its way back, it's going to keep moving forward until it reaches a value of less than 3. Um, as you may notice from this program, it has its limitations. The first one is that the circuit needs to be designed in a way such that the missing section under the circuit has to be in a between a straight line, because the strategy the mBot follows to find its way back is by just moving forward. So if your path takes a turn after a missing section, the mBot is not going to be able to find its way back. Of course, the objective of this program is just to teach a little bit of coding, you know, so it's not too involved or nothing too crazy. It's not going to be Tesla's self-driving cars or anything, but it's definitely going to teach you a few quick concepts on how to build on top of other programs and add some features to things that you had built before. So all that's left now, it's you're going to connect, of course, your mBot, and then you're going to upload your program and test it and make sure everything works. So up next, just a quick show of what it looks like. Okay, so as you can see in this point, the program, you just click, the embed is going to stop at the missing track, which is supposed to be a stop sign. In this case, the video recorded was 3 stops or 5, if I remember correctly. One of those two. Anyway, then it moves on, finds its path again, follows it, and once it finds an object, it's going to stop again. In this case, I removed it from the track, but if you leave it there, before it starts moving again, it's going to check again for the distance in front, and if there's nothing, it will keep moving. So yeah, see you next lesson, and thanks for watching.